today here to talk about data Lakehouse Federation, which basically kind of enables, use Unity Catalog and, the Lakehouse to be able to access external data beyond the lake for external engines and external clients to be able to talk to UC, and for us to basically be better, integrated with the works, with the ecosystem as well as like the different kind of, ingestion partners. And I'm John, on the product management side, looking over Databricks SQL as well as the Query Federation stuff, and I have Todd with me.
Todd, nice to meet you. Product manager on Unity Catalog.
Yeah, Todd's one of our leads on the Unity Catalog side. I'm a bit closer to Databricks SQL, and this has been something that has taken many different kind of teams and across different, different areas of the product to kind of move into. And as always, I need to kind of have the safe harbor statement, which is everything we're going to show you and tell you about is subject to change without any notice. But hopefully we'll get all of them by next week, actually. So let's get started. One of the things I kind of wanted to start it off with is, why are we talking about this even? What's the problem, and why should you care about it? And, as we kind of look at our customers, as we kind of look at their environments, we see, in many cases, there's a lake, there's also a warehouse, there might be more than one lake with different meta stores. There's many databases that, that are used to kind of access either operational data, customer data, some event data, basically that data that has not yet been ETL'd into the lake yet. And I kind of mentioned this too, right? Basically what this ends up being is you end up with many catalogs of many different meta stores for the lake, for the warehouse, for the database, on top of which you're now going to have multiple ways to manage security, multiple ways to manage lineage, not having a central view of across any of these, including like insights. And in some cases, right, like what this could mean is that, you have, for example, I see this a lot in the AWS side, that you have many customers using, Glue with Athena, but they're doing something else on Databricks. There's no exact kind of interrelationship. It kind of is disparate. And as you have these separate compute platforms, data sources, meta stores, or any of these management tools on the governance side, you kind of end up with like much more complexity, which basically leads to a fragmented view, right? So you don't exactly have a central way. It also kind of lives in silos. You kind of have no really central governance or tracking or auditing, right? And finally, there's no really way to interoperate, right? For Athena to come and query something from Delta, UC, or for us to be able to go query kind of them. And the result of this is that there is a need to kind of simplify and collapse a bunch of these together, so you kind of have a simpler single view to kind of manage all of these things. And enter Lakehouse Federation, right? When we say Lakehouse Federation, we're kind of talking about multiple things here. The main Lakehouse Federation piece is the first piece we're going to talk about today, which is basically being able to federate queries, basically push down querying into these external data sources, whether that be like a database like MySQL, Synapse, Redshift, Snowflake, or more like catalog federation like Hive or Glue, and more, right? We basically allow you to kind of integrate all these external data right within Databricks Unity Catalog and kind of use all of this without having to use a separate tool or use a separate platform. The second piece of the federation story is being able to access any and all file types for better interop between like a different query engine, different ETL engine. Some folks use Trino, for example, which is Iceberg heavy. Snowflake has now an internal Iceberg table, so we kind of want to make sure that when you're kind of dealing with data, whether it's like a database or whether it's a file, we support many different options. In this case, it's basically supporting what we call a uniform, which is basically enabling Delta to also act as, pass as a hoodie, as well as an Iceberg file with all the right metadata being kept live, which we're going to talk about later from Todd, and making sure that once you create a Delta table, it's readable and writable by any of these three types of writers. And then the final thing here is, which again, Todd is going to go into detail on the side, is Hive interface. Unlike Federation or Iceberg, which is at the data source level, right, you're kind of pulling from them, the Hive interface is the opposite, right? It's basically opening up Unity Catalog, so all the metadata you're creating, all the permissions, all whatever metadata content you're creating is accessible through any Hive compatible engine. We're going to actually show a quick working demo of this from Athena, but the larger idea is, hey, we don't want to lock you into this, so we kind of want to make sure that on the top end of this too, you can access all of these different data sources. Sorry, all of these different metadata options through a Hive interface. And when you kind of put all of this together, right, these things don't live separately. you kind of end up with a much better Unity catalog, because all of a sudden, not only can you talk to your cloud data lake, you can do catalog federation, you can do database federation, and on top of it, you can kind of bring in any external compute engine so that, if you have any other crossover concerns, you can kind of deal with that. And the nice part is anything on the data source side, the bottom section here, is you're going to get all the benefits of nearly all the benefits of an internal Unity catalog table, right? You're going to get discovery, meaning like you're going to be able to browse this from the data explorer. You're going to get insights on the usage of it. You're going to be able to do lineage tracking. You're going to be able to do permissions on top, whether that's a row level thing, a mask, a regular table permission, and all of that just feels and behaves like an internal table, as well as search, by the way. You're going to be able to search all of this metadata. Cool. So as we talked about the three kind of tiers, let's first talk about the actual federation side, which is basically the query federation and database federation. As we kind of think about the different data sources, right? Where we started is to support the top 8 or top 9 data sources that we were hearing from our customers, whether that be like a kind of an ingest scenario, whether it be a discovery scenario, or whether it's something just like an ETL pipeline scenario. And these like 8 that we're kind of initially thinking about are on the operational side, kind of MySQL, Postgres, Azure SQL, or SQL Server, right? And the DW side, Synapse / its new incantations, Redshift, Snowflake, and BigQuery. BigQuery is going to be a close follow-up, by the way. That's actually launching in August. But all of these other ones I talked about are going to be available starting July 10th, or around plus or minus a few weeks. Don't quote me on the timeline, as a public preview. So you're just going to be able to go into any UC-enabled workspace, whether you're using serverless, whether you're using DB-SQL, whether you're using other like all-purpose clusters. You're going to be able to leverage any of these sources that we define here. As we can think about, kind of going back to the why, we talked about the problem statements, but how does this solve it, right? I'm going to break down this into 3, right? One of them is now in UC, and I'm going to show you in the demo, you literally have multiple types of catalogs. You have your internal catalogs being at the same level as your Snowflake catalogs. So you kind of have this unified view, even at the data explorer level, right? So when you go to a BI tool, when you go to an ETL tool, as you browse the metadata, you can literally see your Snowflake metadata or like your Postgres metadata, whatever the source is, alongside your internal tables. What that means is you can basically do select star from Snowflake.blah blah, join with Delta, join with SQL Server, join with streaming table, whatever the combination is. And it just works and feels like how you're querying any other table in Unity. The second bit is that, in most cases, right, you don't want to have your end users switch between like 3 engines, right? You don't want to go to like, hey, for this go to here, for this go there, for this go here, and then it's going to end up this like huge matrix of items to figure out. So kind of unifying the engine and the entry point. And finally is the governance and auditing piece, right? As all of these queries or usage goes through a Unity catalog, you're going to be able to audit, you're going to be able to govern, and you're going to be able to just get insights, like how much something is being used from a single interface, not having to switch across. So how does this fit in your kind of workflow, right? The way I explain to most, in most customer conversations is federation is great for kind of discovering, exploring, and prototyping, and then always doing all of this under governing. But as you kind of get into production use cases, and production use case could be like, hey, I wanted to do low latency. It could be I wanted to do high concurrency. I wanted something else, right? What we recommend is once you're done with your discovery and prototyping or whatever use case you were doing, especially if it's a latency-sensitive use case, right, kind of leverage as a next step materialized views or actual like DLT streaming pipelines on top of it to kind of even lower the latency of ingest. So what this tells you is we're not replacing ETL, we're just complementing it so that you can get to insights faster and you can start prototyping faster. But eventually, as you kind of go into getting this live, getting this working, especially if you have like multiple layers of views or materialized views defined, you're probably going to want to build a pipeline eventually. But this just jump starts that process and kind of enables quick discovery, quick access, and quick querying. And just to talk about a few customers, like, right, that kind of validate this point on top, and some of these you actually saw in Matei's keynote, is basically like Bayer, for example, right? They have a bunch of different personas, like data scientists, data analysts, that need to access a variety of sources, and the data is not always available in the lake at the right time. Meaning you would first have to submit an engineering request, get that in, get the data in, which basically delays your time to insight. With Federation, right, they can just mount to UC, get started, and then build the pipeline as part of that as well. Kind of similar story with Shell is they're actually trying to move migrate from like one data system to another. And a part of that is kind of enabling more of the use cases to come in Databricks, but they can't do it at once. So what we're kind of seeing is it basically acts for them as a way to kind of enable access to these other sources while through a migration to kind of ease the access problems where you still have like kind of half is on this system, half is on that system. Kind of a similar light, but closer to the buyer story, we have Sega, right? Who basically have a mix of usage telemetry data. They have, sales data, game telemetry data, a bunch of these different sets, and not everything lives in the same place as always. They actually have some of their customer data, I believe, in like one of the databases, whereas some of the telemetry lands in Delta. So what we're doing for them is kind of making it, again, easy so that, data that updates frequently, they do a live query on, but everything else is kind of ETL'd and joined with the use of Query Federation. Any questions so far before we kind of go into a bit more details? Cool. Oh, yeah, go for it.
So where they can run some processing, right, heavy analytics, and that runs faster. So when you bring the data into Unity Catalog, so maybe things may slow or maybe sometimes maybe better. So how you want to address those issues?
What's the issue you were mentioning?
Issue, not issue, like the concerns, right? Suppose the processing, the data analysis processing is better in Snowflake in some cases. And when you bring that data into Unity Catalog, so you can just use that as for data auditing purpose, not for that data process.
Yeah, I mean, a good example of this is like we have a bunch of app databases that we connect to which have indexes on certain fields. And if we were to try to do it, like it would take much longer for us to do. So when we push down the query with a filter, we actually leverage that index, get much faster. In some cases, it's the opposite, right? Some systems might not be great at aggregating. Some systems, maybe you don't want to push analytical queries into the operational system. So it really depends on how you're kind of organizing your environments. In most cases, it's going to be a combination of direct federation, materialized views, and pipelines. And you're going to kind of adjust it depending on like what different type of use cases need when. Yeah. Cool. And we'll have more Q&A times, by the way, so don't worry. But let's actually kind of move forward, and then we're going to come back. One thing I kind of want to talk about is how do these exactly kind of appear in UC? What are the objects? How does it work? To kind of go into a few more details before we go into the demo. So one of the things here is we're now introducing two new object types. One of them is a connection object, which basically is there for holding host port information as well as credential information. And you have a SQL way of managing it, as well as a UI approach for managing it, right? You can kind of create, modify, observe all of the credential management. And once you have a connection object, right, you can then use that to create a foreign catalog. And this is kind of very similar to how Postgres does foreign data wrappers, by the way, right? We're kind of using a connection to create the catalog, and then you can reuse that connection if you want to basically mount multiple databases. What you're seeing on the right-hand side is since UC is a three-level hierarchy, right? We have a catalog, schema, table, and some of these systems are also a three-level hierarchy. We're mapping, for example, from Postgres, one database at a time. But MySQL just has two, so we import all of MySQL in one go. And what this means is that once you create a foreign catalog, right, it just appears in your data explorer or metadata information schemas as just like any other catalog, which is a different property, obviously, but something that you can directly access. You might ask, so how does this work at query time? So what's happening behind the scenes when you submit a federated query actually is pretty simple. I mean, not pretty complicated, but the flow actually is pretty simple. So let's say our query is a simple aggregation query where we're looking at North American customers and grouping them to get the counts by age group. What happens when I submit that in Databricks SQL is that Databricks Query Optimizer, first of all, understands that the customer tables lives, let's say, in Postgres. And then it knows which operations it knows how to translate and push down, which let's say, it could be filters, it could be joins, it could be aggregations, it could be scans, projections, functions, whatever it is. Based on that, it basically translates the Databricks SQL query from the query plan into the dialect of the source system, whether that's Postgres or MySQL. In this case, let's say it generates a SQL query in the Postgres dialect that has a filter, an aggregation, and the scan and project. We're pretty much pushing like 95% of the query in that scenario. And then we get the result back from Postgres. If there was anything we couldn't push down, we do that in Databricks level, and then give you back the result. If you were to do, let's kind of, expand the scenario. Let's say you have two tables there, right? Let's say one lives in Snowflake, one lives in Postgres. What would happen then is, or Delta. Let's say it's a three-way thing. We would pull at that point, since we can't push down the joins because they're in different systems, we would pull all of the data into Databricks, SQL, or whatever you're running this. and from there do the join in memory in Databricks, and then it give you the result. So it's very similar. We try to push down as much as we can, especially filter predicates or kind of aggregations or joins, like kind of restricting operations, into each of the scans, each of the front tables, basically. And whatever we can push down, we complete in Databricks. And that's how behind the scene that works. So our query planner basically knows how to talk Postgres, MySQL, etc. And we have all of these drivers built in to the DBR, so you don't have to worry about any of the kind of, that side. All right, and the final thing I want to say is this works great with materialized views, right? You can basically have a table that you create a select star materialized view on, and then from now on, when you hit that materialized view, you're never going to hit the operational system, but offload it. So that you get better latency, concurrency, depending on what you're trying to do. And this especially helps if you're kind of doing things like a cross-source join or a complicated transformation, which I'm going to show you like a 5-way join between like all of these data sources. Cool. Let's actually jump into the demo, and I'll do the QA afterwards because I'm just worried about time a bit. All right, so I'm going to show a few things. The first thing is actually managing and creating some of these data sources. So let's actually go here to the data tab. Sorry, let me move this over. To the data tab. Here, under external data, you now have a connections option. I can click on create connection. And I'm not going to create the live connection in the UI because you're going to end up seeing my password because I can't remember it. I need to copy paste. But I'll show you one of the ones that are created and the flow for it, right? It's basically as simple as selecting your adapter type, inputting your host port, username, password, as you saw in the SQL version, and then testing your connection, which is going to basically ask you to pick a warehouse. Later on, it's going to ask you to pick a database, and then we'll test the credentials, access, networking, and then if you're good to go, you'll be able to create it. Once you have a connection done, right, you just switch over to the data tab, click on create catalog. Now we introduced a new option here, foreign. Once you select foreign, you have access to all the connections we just showed you guys, right? Whatever you have access to, let's say you want to do a Postgres one. You just input specific database because, as you know, Postgres has many databases in it. We're just going to import one. And then click create. And then what happens is that you land here. Which is something I created before because I put some permissions on top. And we basically pull the metadata, mirror it in UC, and as you query it, we update the metadata. And later on, we're also going to add a way to refresh it behind the scenes automatically, so you don't have to ever touch it again. Even if you're not querying, it's going to be up to date. And one thing to mention here is these feel and work pretty much like any internal UC table, right? You're going to be able to kind of, you'd see the columns. Later on, we're going to be able to import the comments if you have any comments or additional metadata on these systems. You can see the sample data. This is running a query against Postgres just now. I can put permissions on top of it, just like any other permissions. I'm going to quickly show you guys the row level permissions as well, by the way. And very nicely, I can also see lineage. For example, let's pick a table we actually use. Right, and then so it's very nicely, you can kind of see this lineage, whether it's coming from like, Postgres table, am I creating a materialized view table? In this case, I have both. But this basically makes it much easier for me to kind of understand and works with external data sources. Let's actually now switch gears a bit and go through a few quick examples to show you guys. The first thing I want to show is actually, I'm not going to run these because I think you guys got the point, but it's basically about how you manage and deal with this in SQL programmatically. So the syntax pretty much looks like what we discussed over there. The only difference here is I'm using the secret functionality, which is a way to kind of hide and abstract the API keys or passwords or whatever sensitive information you have, so that if you put it in a notebook, in a SQL editor, in some script, you don't actually have to put it in. And then here, the second thing we're doing is creating a foreign catalog. And once I create this, by the way, I can just do a describe on it, like I'm doing with any other database. I can and then it tells me that, hey, it's a Postgres connection, great, and I can see its options. I can do the same on the catalog, right? And then it's going to give me more details about it. And then it's also, you can also run metadata comments, right? You can kind of say something like show schemas in Postgres, and it actually fetches them live and then updates the UC cache. So whenever you're hitting UC, you always get the latest version. And that's how you kind of manage these in SQL. And you can kind of imagine how this could be programmatically managed. The other thing I wanted to show you all is going one level on top and making like the permission management a bit more interesting. One thing we could do is actually kind of put row and column level security on top of these foreign tables. Table level is already understood. You can do table level, you can do schema level, you can do catalog level. But you can also go ahead and, for example, here I'm creating two filters. Sorry, one filter and one mask. I'm creating a zip code filter right here where I only want to get this specific New York zip code or bigger. And then there's also like a way to apply that, right, to a column. So once you have a filter, you can apply to as many columns as you want. So we make that repeatable and manage those objects. Similarly, you can do the same with column masking, right? You could basically kind of do, in this case, what I'm doing is, hey, if you're a member of admins, we're going to show you the postal code. If you're not, we're just going to show you these things. And you can kind of, extrapolate on the logic of social security numbers, credit card numbers, user IDs, whatever you want to kind of deal with. And when you add the Python UDFs, by the way, that are also available in BBC code, you could kind of get creative with what we can do here. And then, yeah, again, applying those permissions are pretty much the same. You just do like an alter table, alter column comment, and then now, anytime someone queries it who's not an admin, they now can't see the zip code anymore. So that was the quick example of row column permissions. Now, changing gears yet again, I want to show a few examples of how we actually query, how that works, what you can do with a bit more interesting cross-querying. So let's get started with a very simple example here, which is basically, I'm doing a select star. So what's happening behind the scenes is we're pushing a scan operation, which is going to be just a select star with a limit, down to the system. In this one, it gets slightly more interesting, right? Basically, not only I'm pushing a scan object to Postgres, but now I'm pushing that postal code filter as well. So that once data hits Databricks, it never has these other postcodes anyways. We kind of reduce the amount we're pulling from the source to optimize the latency. This is kind of, again, opening up on the push-down discussion we had before. And then in this other example, I'm kind of, going one more level where, we have a where clause as well as a group by and an order by. And depending on which data source you're working on, all of these might be pushed down. And by the time you're finished public preview, joins, aggregations, projects, window functions, much more of this selection will be covered for all the 8, 9 sources that we support. And that's how basically the querying side works. But let's say you kind of want to do something more complicated. Let's say it's more of like an ingestion scenario where you are working with more than one source. I have exactly the example for that. So let's actually, oh, no, I'm sorry. All right. So here, we actually have something a bit more complicated. We have churn. This is basically creating a materialized view for dealing with customer churn. And we're pulling the data sources from both Delta, external tables like Postgres, MySQL. But you can kind of expand this to also, like, for example, include like a streaming table as an example, right? All of these can cross-match. In this case, we're basically pulling Delta, Postgres, MySQL, Snowflake. Delta has the churn order stats. Postgres has the events. MySQL has basically the, what did we put there? The website activity. Snowflake has the user activity elsewhere. And then the rest of it is just joining this to the result. And basically, once you join this and you're querying the materialized view itself that's off the join, right, we're not going to go to all of these systems again. So this is a very easy and quick way to materialize something, especially like a complicated join or a complicated transformation, so that your end users, especially think about BI scenarios or like intermediate tables and ETL, right, don't have to go through like a recalculation every single time. And one nice thing with materialized views is that, I don't have it here, but you could add a schedule directly within the create definition itself, so that you don't have to separately manage it with jobs. You can also do that though. It kind of, all of that works together. And before we move forward, let me actually show you the lineage of this materialized view, because this looks pretty cool. I think it was this. Let's just go here. All right, so as you can see, we're kind of joining, in this case, like, from the top, Snowflake, Postgres with 2 Delta tables, sorry, 1 Delta table. I think there's one more at the bottom with MySQL. And then we have 2 flows being created after that. And I can kind of click to see all the columns. I can kind of understand, if I wanted to kind of see like, hey, where else is this being used? I can also see that. There's another view created from that table. So it's very flexible in the way you can do this. And the beauty is, it doesn't matter what type of source you're using, nor it matters like what kind of like object you're creating. It is going to be captured here as long as you're doing the work within Databricks. We do not go crawl Snowflake query logs. We do not query their own logs, so you're not going to see us do anything before that. But everything you do on top will be captured here. And just to kind of get you guys thinking about the use cases, because we talked a lot about this kind of ETL ingest scenario. We kind of looked about the discovery scenario, but this also works with our dashboards, by the way. So you could basically come here to the Federation side, click on. There's under add, you're going to be able to see this dashboard preview, but I kind of get started with something so we can go quick. You can come here. And now this data set is basically select star from this Postgres data set, which has all the pizzerias data and zip codes in New York, right? I can basically update, let's say, hey, I want to see only the pizzerias for this zip code, and then do it. And what it does is it basically just went submit the query down to Postgres Live, got me the results, and now I have this. And this is a very simple example, obviously, but you can kind of see this being expanded. So you could kind of use this for just basic discovery. Although, as I said, right, as you go into more interactive territory, you kind of have to decide on what performance characteristics you want. For just exploration in minutes, this is great. If you want sub-second across hundreds of users, I would recommend backing this with a materialized view first before you do this analysis, so you also don't bombard Postgres. But the whole idea is this is usable in many places, whether you're using from dashboard, whether you're using from DBT, whether you're using from DLT, whether you're using it from kind of a BI tool directly. We kind of want to enable this so that you have access to all of these different data sources. I'm actually going to skip the Q&A section because I don't think we're going to have enough time for Todd otherwise, but we'll try to do one right after the session. No, thank you. Yeah, just share. Do you have a mic?
To this one. Oh, wait.
Oh, it's working.
Okay. You can hear me. Hello?
Nope. Just it's on.
No worries. Okay, that's better. All right, so before we get too far here, I wanted to just show you something really quickly. First, so we built an HMS interface for Unity Catalog, and the reason is we knew that as much as we love all the services and things that we built, we're not the only interface, we're not the only compute engine that you're gonna wanna use with Unity Catalog. And no matter where your data, no matter which compute engine you wanna use, we want you to be able to service these workloads with whatever engine that you're comfortable using. And so we built this interface, and we've got Athena, we've got EMR support, we've got obviously open source Spark. We're just announcing Trino this week as well, so you'll be able to start using that. And I want to show you a quick demo of this, how this works. So let me show you really quickly, because I think it's kind of cool. So here we have, this is the same demo instance that John was using, and we have the TPC-DS database here, and just standard set of tables. And if we just create a table really quickly on here, and we go ahead and create this real quick. And if we jump over to the same thing that I've already connected to Athena, and as John was saying, there's a configuration you have to do for this on the Athena side to be able to connect, but I'm not gonna go through that for the sake of speed of the demo. And you can see, if we look at the tables that we have here, we don't see that table that I created yet, but if I go ahead and refresh, and give it a minute here, in theory, it just takes a little bit. Athena's much slower than Databricks. And you can see now, basically, there's my table. So now I have full, access from Athena that I would just, or any other engine that we're supporting through the HMS interface. You can now access the same data sets, the same things in Databricks through this interface. So we think this is a very powerful tool moving forward and allows you to basically connect various things throughout your journey. And if we jump back over here, let me go back to presentation. All right, looks good. So the other piece, so we did that. So for Trino, it's very easy for us to basically have a configuration to connect to this. And if afterwards, if anyone's interested, I'm happy to show you how this works. But basically, we create a EMR cluster, and then we set this configuration, and then we're able to actually connect through Trino, same thing. And there's other sources coming along. We're going to be continuing our journey and basically supporting a lot more engines as we move forward. And in addition to the first kind of pillars that we've talked about for federation, a really important federation pillar for us is basically being able to support Delta in multiple formats. And what I mean by that is we have our uniform API, which you've probably heard folks talk about for Delta. And what this is for any, no matter where, excuse me. As long as your files are stored in Delta, it's basically, we can access those same things from Hudi, from Iceberg, and the metadata for those are automatically created, and they're stored, and they're co-located with the files themselves. So it gives you a kind of a really nice story to be able to, if you have users that want to operate within Hudi, or they want to use Iceberg, they can still use those through Unity Catalog, and will basically provide the same access to those that you would expect. And ecosystem. This is also a super important piece that kind of ties everything together. We work with a lot of different vendors in this space, and one of the things is it's growing every day. As far as governance, we have a couple strong vendors that we've already partnered with there, and more are coming along. Business intelligence, all the common tools that you're used to using. We have very mature collaborations established with those. And as far as data integration, all of our integration vendors as well are working very close with us. And wanted to highlight one of those really quickly, Amuda, which you've probably heard of. We're working very closely with this team. And one of the things that we've done there is we're already working with them for basically be able to do discovery, for policy pushdown. They can do these things natively. They don't have to use the typical model where they used to of sort of the man in the middle with you'd have to install a jar on a specific cluster. All of those things are going away, and we're making that experience better. And lastly, I'll just say what's coming next is obviously one of the things that we want to go after is more sources. Any compute engine that you want to use through an HMS interface, we want to be able to support that. Whether it's read, write, we're going to spend a lot of time working on these over the next year. And then improved pushdowns and policy performance. This is what John was talking about. There's already a lot that we're doing there, but we're continuing to invest in that. And then for Hive Metastore Federation, you're going to see a lot more coming on this in the future. And then, of course, security and policy pushdown. Like we already said, we have vendors that are doing that now, but we're going to continue to expose these primitives and make things better with things like ABAC. And lastly, on the wait list there, John, you want to talk through that? Or? Yes, we're excited to get you involved. And if there's questions or anything, we've got a few minutes left. We would love to hear some questions. Yeah. User-defined connectors.
So, by the way, here's Andrew, one of our lead developers on the project for Q&A, so we can kind of help answer some of them.
Okay. Hey everyone, I'm Andrew Lee. Like the demo that you just saw from Jen, I was leading the effort to develop that, so really glad to see it going well. Jen actually avoided all the bad things that could have happened really well, so. But yeah, we hope this will be available to you soon, and happy to answer any questions.
So on the data source question, the whole goal with the Query Federation is have a packaged, optimized view of these data sources, including with the drivers, version checked with the versions for all of them, with the right dialect testing. And if we allow for arbitrary custom code right now, that's not something we can deliver, especially on a serverless environment. Because any driver you kind of have us deploy on serverless would be a security hole. So we're kind of trying to avoid that custom scenario, at least where serverless concern. So you're going to see us add more data sources in the short term, but not in a custom manner. So we'll probably add 5 to 10 more within this year or early next. And after that, we'll have to reevaluate where we are in the custom side. Hopefully we cover 90, 80% of the use cases. So from there on, we'll kind of evaluate how that goes.
Here's another question. Does the same thing work for the notebook as well after we set up this utility catalog?
Yeah, any UC supported cluster, great question by the way, is gonna work. Okay, is gonna work with that. Okay. You can just share this one. Yeah. So anything that's UC supported, whether that's an interactive cluster, whether it's a jobs cluster, whether it's something else, it should work. Yeah.
UC external table is only supported for Delta, or it go for CSV or any kind of files, or do I have to use volume?
Volumes and like different file formats is a bit different than this query federation. Once you add a volume, you can basically have multiple ways to parse that. We support all the ones you mentioned, so it doesn't matter. We'll parse that into a delta. We're not going to let you create a CSV table with federation. That would be like a regular external table.
Okay. The gentleman over here.
That. So
I guess we're done.
Oh, we're done? Okay.
Do you have any?
We'll finish. We'll do the last question.
Last question.
All right. Do you have any plans for supporting identities or auth in those connection credentials?
Yeah, we are already working on support for OAuth, and we will do that for a few data sources first, like Snowflake and Salesforce, but really we'll be building the generic OAuth support so that any provider, like Okta or Azure AD, you can use to authenticate, so you don't need to put your username and password in Databricks anymore.
Definitely top of mind. All right, so you're being told that they're kicking us out of the room, so thank you all for joining.
Thank you.